Okay, folks, here is a better version of the 2017 AP number 5 no calculator problem. Once again, this is a DIVA problem, displacement, velocity, and acceleration. Now, no calculator problems are a little different than calculator problems. There's usually a little more concept and less math. If the math looks hard or complicated to do with the arithmetic, it's probably something you're doing wrong. You can probably simplify it beforehand. But remember, with displacement, velocity, and acceleration, if you know one thing and you go down looking for the next thing, you do that by derivating. So the derivative of displacement is velocity, and the derivative of velocity is acceleration. And if you're going up, you go up by integrating. Whoop, right, int. All right, there we go. We go up by integrating. So the integral of acceleration is velocity. The integral of velocity is displacement. Now, on the non-calculator questions, a lot of times you're going to see things that ask us about increasing or decreasing, changing directions. All those are going to occur when slopes are zero. So we're going to do a lot of number line graphs. We're going to identify where slopes are zero. We'll identify key locations. And we'll identify where the slopes are zero. And then we'll look to see if things are positive or negative in between those intervals. And that will tell us about the original graph, whether they're increasing or decreasing. That's the most common thing that happens on these non-calculator problems. And 3 words I'd like to look at as well as we talk about these DIVA problems. And those 3 words are displacement, are distance, displacement, and position. Now, what's the difference between the 3? If we're asked for how the distance something has traveled, and that's the total distance, meaning positive distance traveled adds on and negative distance traveled adds on. And we'll learn when we find that when we do that by integrating the absolute value of velocity, which we talked about the other day. You won't see that a lot on the non-calculator part because you really need your calculator to do the function that way. So distance would be total distance traveled, would be that function right there. Displacement is how far you've gone, and that includes positive velocities. When you integrate, positive velocities get added on. Sorry, positive distance adds on, negative distance subtracts, so you end up with the integral of v. And then the third thing is position. And position is how far you've moved, which is your displacement, plus where you started. If you want to think of the difference, think of it this way. Let's say you know that Josh has run 5 miles. That's his displacement after a certain amount of time. But he started his run 1 mile from home. What was his position after, at the end of this run? His position would be 6, because you'd add those 2 together. Okay, so let's take a look at the first part of the problem. Now, what the AP's been trying to do lately, it seems to be a new thing, is use a lot of different symbols and different techniques for writing things down to try to confuse you. So let's take a look here. We have 2 particles moving along the x-axis, okay, for time 0 to 8. The position of particle P is given by x of p sub t. It's a long, complicated way of saying the displacement of particle P at times t. When I work on it, I'm just going to write down x of p so I know what's going on. And it's equal to ln of t squared minus 2t plus 10. So that's for the first particle. Now, in the next one, they give me the velocity of particle q. So the next particle is particle q, and they label the velocity of that v sub q sub t, meaning the velocity of particle q at time t. And that's a standard technique on a DIVA problem to call your displacement x, your velocity v, and your acceleration a, and use a subscript to identify for different points. They've also given me the information that particle q is at position 5 at time equals 0. And remember, we talked about position. Position means that when that particle starts, it's already 5 miles away from home. Think of it that way. So it says for t equals 0 to 8, when is particle P moving to the left? Well, if something's moving to the left, it has a negative velocity. Negative velocity to the left, positive velocity to the right. If it's hard for you to think of, where it says 2 particles moving along the x-axis, a lot of times in my brain I think it's moving along the y-axis, where positive is up and negative is down. Okay, so in order to do this, I need to know the velocity of particle P. Okay, so I know the displacement of particle p, the velocity of particle p, we're going down one, is the derivative of displacement. So the derivative of the ln of something is 1 over something times the derivative of the inside, which is 2t minus 2. So I'm going to rewrite that via p. I'm going to combine two things into one, equals 2t minus 2 over t squared minus 2t plus 10. So all I'm interested in knowing, to be able to figure things out, is where is the velocity 0 and where is it positive and negative. Once I know where it's 0, I can check all the other intervals out, absolutely no problem. And they've been doing this a lot lately. They've been giving a function that looks really complicated to set equal to 0. If I was to set that equal to 0 and try to solve it, 2t minus 2 over t squared minus 2t plus 10 equals 0. What am I going to do? I've got a fraction, got a lot of work to do. But don't overcomplicate things. The only way for this thing to be equal to 0 is for the top to be equal to 0. I don't have to worry about the bottom. The bottom being 0, the bottom has nothing to do with it. That just decides where it has no values. I want to know where 2t minus 2 is equal to 0. So I can add 2 to both sides. I got 2t equals 2. Divide both sides by 2. And I've got t equals 1. So that means when t is 1, I know that slope, the velocity, is 0. And at no other times that's going to happen. So now all I have to do is test a point on either side of that to know what's going on with it. I can pick any point on that interval. So on the left side, I'm going to put 0 into the equation. I'm going to put 0 into the equation. I'll use green for that. And I'm going to get negative 2 on the top. And then I'm going to get positive 10 on the bottom. And negative 2 over 10 is a negative number. I don't care about the number itself. I just care that it's negative. You'll notice in a lot of these non-calculator problems, we don't really care about the actual number. So I know on that side it's negative. And so now I've got to test the other side as well. And my suggestion is pick a really big number. Now I can choose a number between 1 and 8 if that makes you happy. I can go farther off because I know it's not 0 anywhere, but just to keep it simple, let's put a number in there. Let's put in 5. So on top, 5 times 2 is 10. 10 minus 2, I don't care what it is, but 10 minus 2 is positive. Okay, 5 squared. I'm doing the bottom now. Let's do this in orange. Oh, I lost my negative. There it is. Okay, so 5 squared is 25 minus 10. Okay, so if I fill in 5, I get 25 minus 10 plus 10. And you can see that math ends up working out pretty easy, but I don't care about the numbers. Minus 10 plus 10 goes away, so I know the answer on the bottom is positive, so the whole thing is positive. So that means the graph goes down, which is to the left, and then the graph goes up, which is to the right. So for part A, when is the particle moving to the left? It is moving to the left between 0 and 1. If you want to write it in math terms, we can't necessarily say the other parts on there, but I would put this on my answer because it verifies what I was doing. Okay, let's take a look at part 2. I'm going to stay on this page for just a second, then I'm going to flip to a working spot. For times 0 to 8, find all times during which the two particles travel in the same direction. So we know the directions that's happening in this part right here. So now we're going to make a number line graph for the other chart. And let's see what we have. On the other chart, we already know the velocity. So we don't have to compute the velocity from a different piece of information. But I have to figure out when that right there is equal to 0. And you'll always notice your factoring is going to be pretty straightforward. First, if there's a common factor, take it out. There isn't here. And then here we're just going to factor this one into two terms. A t in each spot. I need factors that multiply to positive 15 to get me to negative 8. That would be negative 5 and negative 3. And set each of those equal to 0. And I get t equals 5 and t equals 3. So those are the values where the velocity is equal to 0. So I'm going to fill those on in. Here's 3. Where I put them doesn't matter. And here's 5. And now I'm going to test. I'm going to find numbers in those intervals and see where they're positive and where they're negative. First, I'm going to put in 0. If I put in 0, I get a positive answer. Okay. So in that interval, when you put in 0, it's going to be positive. I'm going to put in a number between 3 and 5. I'm going to put in 4. And I normally use the factors. It's just easier because 4 minus 5 is negative, and 4 minus 3 is positive. So in this interval, the velocity is negative. And let's pick a number between 5 and 8. Let's go with 8. 8 minus 5 is negative. 8 minus 3 is also negative. A negative times a negative is a positive. So then these intervals, up, down, up. You can think left, right, left. I think up, down, up is easier to think about. I'm okay with that either way. So now we've got to figure out when the two particles were traveling in the same direction. So I'm going to look back at the first one to see when the first one was positive. The first one was positive between, oops, thing. Let's use a different color for this. Hold on. Back to there. Let's get a new color. 8. Oop. Sorry, the velocity here is positive between 1 and 8. So let's look at the other function. So that velocity was positive between 1 and 8. So where do the velocities match up? They match up between 1 and 3 and 5 and 8. So they're positive there. I can check the negative ones. This one's negative between 3 and 5. This one's only negative before 1, so there's no negative spots that match up. So the answer for part 2 is between 1 and 3. I forget to write the word between on there. Between 1 and 3 and 5 and 8. Okay, part C. It says find the acceleration of the particle Q at time 2. Well, I'm looking for acceleration. So if I have for Q, I have velocity, so I'm derivating down. The acceleration is going to be the derivative of velocity, which is 2t minus 8. And they want me to tell if the speed of the particle is increasing. They want me to tell if it's speeding up, slowing down, or neither at time t equals 2. So for that, I need the velocity at time 2. Velocity of Q at time 2. I need the velocity, I need the acceleration of Q at time 2. If you don't use these same symbols, if you just write Q, velocity of Q at 2, acceleration of Q at 2, that's fine as well. So I'm going to put 2 into the velocity equation, and I am going to get 4 minus 16 plus 15. And down here, I'm going to acceleration. I'm going to get 4 minus 8. You can find the actual number. We have to find the acceleration. The acceleration is negative 4. And the velocity, and if you work the problem backwards, sometimes it's easier. Negative 16 and 15. 16 and 15. So it's negative 1. 4 minus 1 is 3. So this is slowing down because V is positive and A is negative. That's our. We're always going to be, whenever they want a reasoning for something, it's almost always like speeding up or slowing down. You're going to talk about the two different things on that piece right there. Okay, the last one, remember, the D question parts are almost like bonuses. If you can get part of them right, great. If you can't, don't worry about it. It's okay. It's not mandatory if you're doing well on the test. Find the position of particle Q the first time Q changes direction. So when did Q change direction? Let's go. Q changed direction at 3. Okay. Now, if you got that wrong and used a different number, you'd still be okay. They'll still give you the credit for the problem. They won't penalize you at all. So we know change direction at time equals 3. So if I want to find the displacement, I want to find how far it's gone, instead of taking derivative, now I'm going up, I'm going to integrate. I'm going to integrate from time 0 to time 3, t squared minus 8t plus 15. Now this is about the max they give you when you have to integrate. I'll put the dt on there, equals. In terms of the math they have you do, so this would be t to the third, with a 1/3 out front, minus t squared, with an 8/2 out front, which is 4. You don't have to simplify if you don't want to. You can leave it there, plus 15t from 0 to 3. Now, I already know, if you take a look, I'm going to do upper minus lower. When I fill in 0, this happens pretty much in all these, that whole thing is going to go away. So I'm going to say x of q equals 1/3, 3 to the third, minus 4 times 3 squared, plus 15 times 3. You don't have to do any more math to find x of q than that. If you don't want to solve it out, you don't have to. But I'm going to solve out this displacement anyway. So I'm going to do 3 times 3 is 9, times 3 is 27, divided by 3 is 9. 3 squared is 9. 9 times 4 is negative 36. And 15 times 3 is positive 45. So when you combine those all together, if I take 45, positive 45, negative 36, positive 9, put them all together, I get 18 when I combine them together. That's the displacement. That's how far from when I started, how far I moved. Now let's just take a quick peek back at the problem. Are they asking me for a displacement? They are not. They're asking for a position. Position is, first of all, how far away you started, combined with how far you moved. And there's a piece of information I didn't use before. The position at time 5 was equal to 0, so my position is equal to 18 plus 5, which equals 23. If you didn't want to do any of the math on that, you could literally write the answer out for position like this. Written out like this is 100% totally correct as well. You're not required to do any of the addition or subtraction on there as long as you have your answer fully worked out. Okay, I think I did a better job this time. I know it's a little bit longer. Sorry about that. And I will see you in class tomorrow. Take care.